Hello friends, today we will discuss about the assignment of signals for the different protons, and this topic from M.Sc part 2 organic chemistry and paper is CHO 351. Now we will see the one example regarding this. Now this is the example. The molecular formula of this is C20, H24 and O5, and these are the various signals for different protons. Now when we count the number of protons, for tally the number of protons and number of signals. Now here when we count, this one is 1, 2, 3 and these all these are the 24 protons, okay, and carbon is also 20. Now here with this addition there are two experiment is done with this compound, that is spin decoupling experiment and nuclear Overhauser enhancement experiment. Now here when we consider the decoupling experiment, here when 1.79 this signal, this proton is double irradiated, here there are change takes place at 5.26. here originally it is multiplet. See here, this is originally multiplet, but after double irradiation it falls to triplet, and J value is 6.6 Hertz. At the same situation, when 5.226 this del value is spin decoupled, and here 3.47, originally it is doublet but it falls to singlet. Now here when we consider the NOE experiment, nuclear Overhauser enhancement experiment, here when 3.91 del value this proton is double irradiated, there are 6.64 this is enhanced by the 50%. Okay, now we will discuss about the assignment of signal for these various protons, and with explanation or justification of spin decoupling and NOE experiment. Now we will write the this structure again here. This is the benzene ring, OCH3 methoxy group. Here also one proton, OCH3 group. Okay, now we will assign the proton in the structure one by one. Now here this A 1.79 del doublet, J equals to 1.2 Hertz for 3 hydrogen. Now this 1.79 means it is a shielded region, it present at shielded region, and hence here it give to this 1.79 del value, and it is doublet. Why it is doublet? Because it is coupled with this proton. This CH3 is coupled with this proton, and hence it gives the doublet. Okay, now this is assigned. Now when we consider the 1.85 singlet for 3 hydrogen. This is for these 3 proton 1.85 del, and this is singlet because there are no neighboring proton is present here, so this is assigned. Then 2.13, this is again singlet 2.13. Then when we move toward this 3.02 del value, singlet here 3.02 del value, again here it is singlet, okay, for 2 hydrogen, 2 protons. Then 3.47 doublet, J equals to 6.6 hertz. Now 3.47 here, 3.47 doublet and J equals to 6.6 hertz, 6.6 hertz. Now it is assigned. Then 3.91 singlet for 3 hydrogen. Now here 3.91 because here oxygen is present and it is de-shielded, it is de-shielded, so 3.91 singlet, okay. Now this is also assigned. Then 4.07 it is de-shielded, and here this one 4.07 del and it is singlet, Then 5.19 singlet for 2 hydrogen, 5.19 here because here oxygen is also present and here CO group is also present, and near to phenyl ring is also electronegative nucleus, and hence it is more de-shielded, so 5.19 it is singlet, okay. Then 5.26 multiplet, here 5.26 multiplet. Why it is multiplet? Because it is coupled with this one, this CS3, also it is coupled with these 2 protons, and hence it gives the multiplet, okay. Then 6.08 here, 6.08 singlet for 1 proton, and last one is remaining 6.64 here, 6.64 singlet, okay. Now here all protons are assigned and it having the different values of the chemical shift depending upon the environment, okay. Now we will move towards the decoupling experiment. Now here irradiation at 1.79 del, see here 1.79 del. Now here 1.79 del when double irradiation 5.26. Now see here 5.26 is originally multiplet but it falls to triplet, means here the spin decoupling experiment will be happen in between this 1.79 and 5.26, okay. Double irradiation means the coupling in between this CS3 and this proton is a disappear here, okay, and hence this 5.26 is only coupled with this 3.47, and hence this multiplet is falls to triplet because neighboring protons are 2, and hence by the rule n+1 this multiplet is falls to triplet and J equals to 6.6 hertz. Now here prove that this having the J value 6.6 Hertz, and at the same time this 3.47 having the value 6.6 Hertz. When coupling constant values are same, these are the coupling partners. These are the coupling partners. So this 5.26 after decoupling 5.26, there are only coupling in between 5.26 and 3.47, and this is multiplet is false to triplet because there are neighboring protons are 2. Okay, so it is prove here these are the coupling partners. Then another experiment, when 5.26 is decouple, means here 3.47 originally it is doublet, it falls to singlet, because there are no coupling in between this 5.26 and this 3.47, and hence there are this 3.47 is originally it is doublet, it falls to singlet, okay. So this is the decoupling experiment. Now when we move towards the Yanoi experiment, here Yanoi experiment is apply on the 3.91 this signal, and when we will double irradiate this 3.91 signal or proton, 6.64 this signal is enhanced to 50%. This is enhanced to 50%. What is the meaning of this? Meaning is that the distance in between this 3.91 and 6.64 is less than 4.5 angstrom. It is less than 4.5 angstrom, and it is proved that this OCS3 and H are nearer less to the 4.5 angstrom distance. Okay, and in this way we discuss about the different signals with different chemical shift value, and it is assigned in the structure, as well as we also discuss the decoupling experiment. Again we will see the decoupling experiment here. Now when we 1.79 is double irradiated, there are the coupling in between the CS3 and this H is disappear, and hence originally 5.26 is multiplet, it falls to triplet. Okay, it falls to triplet, and having coupling constant value is 6.6 Hertz. So it is the only coupling in between these 5.26 and 3.47. Now when we consider the another double spin decoupling experiment with 5.26, here 5.26 when double irradiated, there are no coupling takes place in between the 3.47 and 5.26. There is 3.47 originally it is doublet, it falls to singlet, and hence it is a proof that 5.26 and 3.47 they are coupling partner, as well as 1.79 and 5.26 these are also coupling partner. Okay, and another experiment is nuclear Overhauser experiment. Here 3.91 this signal is double irradiated, this proton is double irradiated, and here the intensity of the 6.64 singlet is enhanced, it is enhanced by the 50%, because the distance in between this CS3 and this is proton less than 4.5 angstrom. Okay, thank you.